words cannot describe how much I appreciate all of your comments on the videos. I read every single one. If there's anything you can do for your professor or for your coworkers or your boss or your employees, if you are the boss, the best thing you can do is communicate. And especially for me, just as kind of a teacher here, my favorite students are generally the ones that communicate and ask questions. The ones I naturally learn their names because they come up after class and they engage with me during class. They're not afraid to raise their hand and ask a lot of good questions. And so for those of you participating on the comments, all right, big deal for me because, I don't know most of you out there, and it's nice to get to know you and engage with you. So please keep these comments going. Now, I wasn't planning on making a YouTube video just to cover the comments on the last video in this playlist. If you go to the top here, linear search proof of correctness. Oh, look at that. I paused it where I'm going over comment. This is a video going over comments inside of a video going over comments. Okay, I didn't plan on making this video, but the comments are so excellent. I thought, you know what, I really have to follow up on these comments. So what I'm going to do is pick out a few of them. A lot of the comments said the same things, so if I don't pick on yours, don't worry about it because you probably said something similar to the other person that I pulled out. And I'm going to respond to some of these and talk about them a little bit because this is a huge deal, testing your code and making sure your code works. Here we go. I wish I knew how to pronounce your name here. Andrea Yablonsky. Forgive my ignorant American English ways. Tell me where you live anyway. I love the names. The algorithm is correct if it maintains its invariant through all possible outcomes. In case of search, we have two expected outcomes. Excellent. Either hit or miss. By testing these cases with predefined expected outcomes, for hit, I is within 0 to n-1. For miss, it's -1. We can prove that we maintain the invariant. Therefore, the algorithm is correct. Love it because that's the mathematical way I described correctness. And for the hardcore algorithmic people, they're going to want to know, how are you setting up your initial case? How are you maintaining it? How do you terminate? Those kind of things. Everything we talked about. What are the invariants? And I think that's excellent to talk about it that way. But I'm also kind of a cowboy, meaning I just want to code, and I want to beat up my code, and I want to ensure that my code works by beating up on it. So there are a lot of you said unit tests. All right, now if you don't understand what unit tests are, I have a ton of unit tests, especially at the beginning of the Game Engine Programming playlist. Here, I'll pop up an annotation right here, and it tells you all the videos that you can go and see me do some unit testing on. Unit testing is super important. Basically, writing unit tests is a form of writing code to beat up your code. And I've used unit testing extensively in my professional life, tons of it in my coding I do at university level. Huge deal. But unit testing has its cons, and the cons are they take extra time. Now, there are those who argue that you don't have time to not unit test, which basically means if you're not unit testing, you're losing time in the long run because somebody's going to find your error somewhere, and hopefully it's not a customer or a client that gets mad and fires you. So unit testing is pretty important. But I've spent plenty of time in industry to know that we have to ship this product and we have to ship it out the door. And I just don't feel like I can write unit tests now, even though I know in the long run it might save me time. But we just got to get this out the door. And so unit tests go out the window. And the other alternative to that is, well, you just test it yourself. Or the alternative is you chuck it over the wall and you give it to the QA people and you say, please, QA stands for quality assurance. Quality assurance QA people, please test this code and please don't find any bugs. And if you do, though, report them back to me and I'll fix it. And then you get a long list of errors back. And having those second eyes test your application, loving it. But as a primary means of finding the errors, no, not a good way to do it. David Moncada, my mantra has always been to code a little, test a little, code a little, test a little. One thing that you'll hear about unit tests all the time is, oh, you write all the unit tests up front. That's a bunch of bull. You don't write all the unit tests up front. What test-driven development really is, and I use this a lot in my Game Engine Programming playlist, is you write a test to beat up a certain piece of code, and then you go write that code. Come back, write another piece of test to beat up the next piece of code you're going to write, and then write that code. Repeat, repeat, repeat. And what's nice is you can first see the unit test fail. you write the code, and then the unit test passes. It's almost like you're extending the compiler. Every time we build and the compiler gives us back errors, we're like, oh, glad you caught that, compiler, and you fix all those errors. And then eventually you build and the compiler says, oh, hey, you got all the errors. And we get this warm, fuzzy feeling inside like we should ship it. But if you've programmed more than a week or two, you know it's not time to ship it. That's just the beginning of your testing. When you write unit tests, if you have your build environment automatically execute those tests on your code, you've extended the compiler. Yeah, you're not extending the compiler like compile time checks, but what you are doing is having all these little tests go boom, 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 boom through your code, and if everything comes back good, you get an even extra warm, fuzzy feeling because you put in the extra time to write the unit tests to beat up your code. And what's super excellent about unit tests is if you have thousands and thousands of unit tests in place, you've been working on the project forever, and you need to go change something or fix a bug that QA came back with, you can change that code, and then you can immediately find out if you broke something else. Because you run the unit tests, there you're running thousands of tests automatically against your code, and then immediately you get a report, and you say, oh, cool, I just changed that, and that broke that, and I need to go figure out why, and then it does some checks and balances. Whereas if you don't have those unit tests in place, check it in, QA test it, oh, it's great and dandy, and then all of a sudden you broke something else, but you don't find out till like weeks later, and by then you're so out of context, you're like, what did I do to break that? You're spending hours to find where you broke, and then when you find it, you're like, oh, yeah, I changed that forever ago. Oops. If the unit tests are there to immediately tell you, no, you just saved all that time, and you get to sleep more at night. One other thing before I leave the unit testing topic, I do a lot of print statements myself to kind of mentally and visually check the code. That's fine and dandy, but if I don't turn that into a unit test, then the console's a waste of time. So yeah, okay, use the console to get familiar with your code, but cement it in a unit test. What's nice about a unit test is if you say assert whatever equals something, I can see that directly in the code. I don't need to switch over to the console to see what the output was and verify that's what it should be. The assert or the unit test immediately tells me right there in code what the value should be. And if it fails, then I know that's exactly where I need to go fix and debug and look and investigate. Here's another one on unit testing. Don't test for just correct values. Test for errors. You can write unit tests to check for an error. What you do is you feed your function some crummy data where the function should throw an exception. You set up a try catch and you catch the error. If you catch the error, everything's dandy and fine. But after you call the function, make sure you put an assert false there. And if your function doesn't throw an exception, then that assert false will get hit and you know that the exception wasn't thrown by the function when the function should have thrown an exception. So good thing to point out there, Matthew Hallmark. Widowmaker, I see your conversation with Shade the Artist. Try breakpoints. Make sure you're in debug mode. Stepping through your code with a debugger, excellent way to learn if your code's correct. One nice thing I like doing at one of my jobs was we had to do code reviews before we checked in. And that doesn't mean review your code with all your developers. It means pull in another developer and talk through your code with the other developer. And generally, it's you finding the bugs instead of the other developer, because as you explain your algorithm, you're like, wait a minute, why did I do that wrong? That doesn't make sense. As I talk through it, I don't know what I was thinking. Okay, excellent way to find errors. One of my best bosses ever told me about this barking dog theorem he had. Basically, he wanted to get a dog, and anytime anyone had a problem, he'd send the dog into the cubicle, and you'd talk through it with the dog, and the dog was just trained to woof whenever you stopped talking at certain points. And as you talk to the dog, you'd find your own errors. My boss thought we'd save a lot of money on developer compensation that way. So here's a comment that caught my eye. I was surprised to find that at the time of writing this comment, none of them have mentioned mental check the code. And then you go through and you talk about it, and then ITA6AKI responds, hey, checking mentally has its limits. That's true. Definitely true. If all you do is a mental check, okay, don't do that. Especially when you don't know something well, but then Traja comes back. Of course it does. Still, I think it's good practice. At least I hope it helps you understand your code and functionality better. Okay, this goes back to using the debugger. Yes, step through with the debugger. Watch the variables in the watch window. But something I used on my son when I was first teaching him assembly programming was I wouldn't even have the computer execute the code. I would say, no, you have to be the computer. You have to step through the code. You need to draw the RAM and the stack and everything that's going on. put your instruction pointer in there, and literally we would execute the code on paper without using a computer. Algorithms predate computers. We already talked about that. And so we would execute his code on paper, and he learned so much, and the learning process was so much better. One reason I think a lot of you like my YouTube channel is I use this tool up here. It's called Ink2Go. If you're curious, the Ink2Go guys are great. But I'll draw and I'll make all these diagrams and arrows and things. And it's amazing how you can draw a box and it means 10,000 things because you've drawn it 10,000 times to mean different things. But I think a lot of you appreciate my illustrations. At least I love my illustrations because that's how I learn. And so you'll see as I'll execute code, I'll draw a lot of pictures to illustrate what's going on. And I think you guys appreciate that. And we can really draw pictures and execute the code without a computer. And I would agree here with the Traja is mentally check your code. Not just look at it and say, oh, it looks good, but step by step execute it. Draw the RAM on paper, draw the stack on paper, draw the call stack on paper, your local variables, all that. Get comfy and comfortable with your code because you will find most of your errors that way than you will with unit tests. Player Zelda kind of says the same thing here. Well, it's pretty simple. When I want to ensure my code is working correctly, I'm switching to a notepad. Yeah, the real thing outside the computer where you can scribble on with a pencil. Oh, that's so gorgeous. Player Zelda, you make me feel so good. By the way, Player Zelda, I hope that's understandable. It's not only understandable, it's gorgeous. And it almost brought a tear to my eye. That's awesome.